Welcome back to B-Spice. In this session, we'll talk about quality measurement and design, part one. Okay. So, yeah, this is more of, analyzer. Okay. So, design of analyzers and its application, all those aspects we are going to cover. And of course, we are going to discuss this in parts. So, then part one, what we will focus is quality measurement of process stream. Okay, just an outline. Okay, then the terms of definition. There are a lot of terminologies are there. We need to understand first before proceeding to the details of each analyzers. Then we also touch upon, with the help of a schematic, what are the major components in an analyzer system. So these three items will focus in part one. Okay. Then subsequent sessions will focus on major type of analyzers, online analyzers, fixed gas detectors, flammable gas detectors, infrared sensors, pH analyzers. In fact, pH analyzers we have already uploaded, but my intent is I want to give everything in one playlist under quality measurement. In fact, the pH analyzers, oxygen analyzers and TOC, all we have already covered as part of mastering analyzers, videos. So this, I want to give a concise concept uh, uh, related to the quality in, under quality measurement design playlist. Okay, so that's it. Okay, so to continue with this, pH analyzers, conductivity analyzers, gas chromatograph, very, very important, GC. This is also we are going to cover in detail actually. Then hydrocarbon, oxygen, like zirconia probe, infrared analyzers, turbidity analyzers, total organic carbon, TOC, the typical analyzer system, typical AMADA system, typical analyzer network, and of course the design considerations and typical sample takeoff probe. All this we are going to cover, friends. It's all depends on your support. The more you support, yeah, I'm willing to conduct all this session in detail. Okay, right. So quality measurement of process streams. Okay, so now to understand this, we should know what is an analyzer. Of course, everybody knows, but just a refresher. Analyzer is a device, okay, that facilitates the analysis of something, some process medium, right? Usually by separating it into its constituents part or making direct measurement. So this is a simple explanation, right? So it's basically an instrument or device which conducts chemical analysis on samples or sample streams such as liquid or gas. Okay, very clear, right? So many analyzers perform such analysis automatically. That is the point, on a continuous or intermittent cycles. So this is about the analyzer. I hope nothing more to explain in this, right? Very simple, right? Now we go into the advantages. As you know, over the past few years, it has been proven that having an online analyzer assists in optimum operation and have drastically improvised the quality of products. I hope you agree, right? Yes. So that is the advantage. So due to this, analyzer field has improved in a faster rate. Yeah, very rapid, right, friends? Okay, good. Now I go into the details of terms of definition. Online analyzer. What is this online analyzer? An analyzer that is used to monitor the material content at various stages in flotation or other, processing flow sheets, other process. See, flotation is related to mining actually. Okay. So that allows for material balance accounting on continuous basis. This is the online analyzing. Okay. Then online analyzer actually that are connected to the process. That is the point. Online means it's connected to the process and conduct automatically sampling. Okay. So can be called an online analyzer or sometime inline analyzer. Okay. So this is the typical definition of this online analyzer. Then what is a continuous analyzer? Single component analyzer that receives a continuous flow of sample, either liquid or vapor through the detector. So that is the continuous analyzer. Okay. So here one point we need to take note. Response to the changes in the process stream are solely dependent on the time required to transport the sample from the process to the analyzer. So that is the point. So basically the response is solely depend on the time required to transport the sample, okay, from the process to the analyzer. So this is about the continuous analyzer. This is all very pretty straightforward statement, friends. I hope it's very clear, right? Okay. Now, gas detector and portable gas detector. See, basically here, a device which detects the presence of various gases within an area, usually as part of a system, what for to warn about the gases which might be harmful to humans. That is the point here. So it detects the presence of various gases within an area, right? So usually these are fixed or portable. Okay. So placed in a suspected potential area, right? Okay. So laboratory analyzer, simple. See, normally we take the sample and brought it to the, lab and we do the analysis. That is this. So your device provides control condition in which the experiments and measurement performed for process samples or quality of intermediate final product. So whatever is analysis is done in a lab. So that is, laboratory analyzer, right? For example, GCs, gas chromatograph or melt flow index, etc. Okay, good. So few more to add on. Response time. So basically, this is the time between the actual change in the process stream until the change is reported by the analyzer. Okay, so this is a simple definition. And we also need to know the check gas or calibration gas. So it's basically a known gas or a mixture of gas or a liquid used to calibrate or validate the analyzer. What for? To ensure the reliability of analyzer performance. So this is about check gas or calibration gas. Then hot room. So simple. This room maintained at high temperature. What for? To ensure sample line containing process fluid are kept at higher elevated temperature. For example, in a glycol unit, a hot room. Okay. Then cold room. See, this room is maintained at low temperature, that is around 20 degrees centigrade. What for? To keep all the electronic part in cool condition. Simple. Analyzer building. You would have seen analyzer buildings, right? Yes, that's it. So this is the complete terms of definition, friends. Now we go into the detail. Major components. So this will give you a complete idea. Okay. So I'll just come from this side, friends. You see here, this is a line, right? Sample point, sample takeoff probe, right? So you have an isolation valve. Then it comes to the sampling preconditioning system. Now, this is located in field close to the sampling point. Okay. Then it goes to the sample conditioning system. So it is here, the gas, all these are there. Okay. Then you remember the fast loop also we discussed some time back. If you are a BSpice member, you know that. So this is a fast loop bypass and this is for the relief outlets. So this is actually a sample recovery system. Okay. So this is goes to the sample return point actually. Okay. Right. So after the sample conditioning system, it comes to the analyzer. Then from this analyzer, we have analog, digital, all these. Okay. And this actually goes to flat and this goes to the atmospheric wind. Of course, we have the utilities like, instrument air supply, nitrogen, all there, and the power supply. So this is a typical, major components in an analyzer system. We will discuss this one by one in detail. Okay. Right. Now, sample takeoff and transportation. Okay. So basically sample thieves or sample pumps, we call it as. Okay. So basically this is extraction type online, right? So it consists of a special tube bundles. Can be a non-heated or heated or electro-polished. Okay. So this is the sample takeoff and transportation. Okay. This is a sample takeoff and transportation. Okay. Then sample conditioning. What for sample conditioning? So this is designed to cool and clean the sample. Very simple, right? Yes. So have primary or secondary bypass loop to reduce the lag time, right? So it incorporates the facility for validation, calibration check, and lab sample. All this can be done using this sample conditioning system. So here we take off and we do the conditioning here. And the sample conditioning proves a constant back pressure for proper functioning of, sorry, not proves actually, sorry, typo error, provides constant back pressure for the proper functioning of the analyzer. Okay. So I want to also add one more note here. For inline analyzer, this is not applicable because that is inline, right? So here the sample, all these are not applicable. Just remember, friends. Right. So to move on, Analysis. For online analysis, for online, basically this is, for online density or moisture analysis, this is done directly. Okay. For all others, actually, the analysis is done in the analyzer. You got it, friends? See, what is the analysis? See, basically for online, like, density or moisture measurement, analysis is done directly. For other system analysis, other parameters, other analysis is done in the analyzer itself. So it's importantly, for gas analysis, same quantity of sample needs to be injected to the analyzer. That is also we need to take note. For a gas analysis, same quantity of sample needs to be injected into the analyzer. I hope it is clear. Any questions, you please comment or you can write to me. Okay. This is about the analysis. So we are discuss sample takeoff and sample conditioning, and this is the analysis section. And here it is sample return. So return from the primary bypass and analyzers are routed for safe disposal and vent. So this is just for a recovery. Okay. For a safe disposal, right, friends? So this is about the sample return. Then how about the communication to DCS? So basically we have all these options, 4 to 20 milliamps and data highway, all these actually, right? And OPC, right, friends? So that is about this simple session. And this is something basic. And as I informed in the beginning, we are going to cover this item, all these item. I mean, whatever we are listed around 21 topics, right? Only 3 topics we have covered, and remaining 18 topics we'll discuss in the subsequent session. And I request all of you to support this effort. Okay. Thanks for watching and see you in the next video. Take care. Bye-bye.